Batteries and electronic components have become an essential part of everyday life. They are found throughout homes, schools, offices, warehouses, medical facilities, repair shops, manufacturing operations, transportation systems, and commercial environments. As technology continues to expand, households and organizations are encountering increasing quantities of batteries and electronic components when devices are repaired, upgraded, replaced, or permanently retired. Some equipment may still be fully functional. Other devices may require only a minor repair, while damaged or obsolete electronics may need to be prepared for responsible recycling. An organized management program can help reduce unnecessary waste, protect sensitive information, improve workplace safety, and ensure useful materials are not discarded prematurely. Battery-powered technology extends far beyond phones, tablets, and laptop computers. Power tools, cameras, wearable devices, medical electronics, emergency equipment, robotics, communication systems, wireless sensors, and portable diagnostic tools all depend on batteries. Many of these batteries are built directly into their devices. Because they are not immediately visible, they can easily be overlooked when equipment is placed into storage or prepared for disposal. Removable battery packs can also accumulate separately during maintenance and replacement programs. Without clearly marked collection areas, these batteries may be left in repair rooms, drawers, supply closets, or ordinary waste containers. Modern electronics also contain a wide range of internal components, including circuit boards, processors, displays, cables, sensors, motors, fans, memory devices, and power supplies. Each component may require a different management decision. Responsible handling begins before equipment is discarded. Maintenance, repair, reuse, accurate inventory records, and proper separation can extend equipment life and support better end-of-life outcomes. Retired electronics should not be treated as one uniform material. A single device may contain metals, plastics, glass, wiring, batteries, circuit boards, mechanical hardware, and data storage components. Circuit boards connect the processors, memory, sensors, and communication systems that allow modern devices to operate. These boards should be protected from moisture, heavy impacts, and unnecessary contamination during storage. Power-related components form another important waste stream. Batteries, transformers, chargers, adapters, and power supplies should be properly identified and separated. Damaged power components should never be mixed casually with functional equipment. Displays may require additional protection, particularly when screens are already cracked or separated from their housings. Proper containment can prevent further breakage and reduce the release of loose fragments. Cables, adapters, motors, fans, sensors, and switches may still be useful. When these components are identified and stored correctly, technicians may be able to use them to maintain compatible equipment. Large machines present an even more complicated challenge because electronic controls are often combined with metal frames, plastic panels, batteries, motors, and other mechanical parts. Reviewing the equipment before removal can prevent important components from being overlooked. Before electronic equipment is moved, stored, reused, or recycled, it should receive a basic visual inspection. Employees should check for broken housings, exposed wiring, cracked displays, corrosion, missing protective covers, and signs of battery damage. Equipment that still works should be identified separately. A device may have been removed from service because it is no longer needed, not because it has stopped operating. It may qualify for reassignment, refurbishment, donation, resale, or another approved form of reuse. Partially functional devices may also contain usable components. A broken display does not necessarily mean the power supply, memory, motor, or communication module has lost its value. Inspection results should be documented using simple categories such as working, repairable, damaged, obsolete, or awaiting evaluation. Labels should include the inspection date and any condition requiring special attention. Battery condition is one of the most important considerations during electronic waste handling. Organizations should identify equipment containing removable batteries as well as devices with sealed internal batteries. Manufacturer labels and equipment documentation can help employees determine the type and location of a battery. Swelling is an important warning sign. A swollen battery may push against the device enclosure, lift a keyboard, separate a screen, or distort an external panel. Leakage, punctures, crushing, discoloration, deformation, and unusual heat should also be treated seriously. A questionable battery should not be returned to an ordinary storage shelf or mixed with intact batteries and electronics. If a battery becomes warm while it is not operating or charging, employees should report the condition immediately and follow established workplace procedures. Loose batteries may also have exposed terminals. When those terminals contact metal objects or other batteries, unintended electrical contact may occur. Appropriate terminal protection and suitable storage containers can help reduce this possibility. Employees should never be expected to guess what to do. Procedures should clearly identify who must be contacted, where questionable batteries should be placed, and how the surrounding area should be managed. Effective separation makes battery and component waste easier to manage. Loose batteries should be separated from complete electronic devices, and damaged batteries should remain apart from intact battery inventory. Complete electronics can be grouped by category, such as computers, tools, communication equipment, medical electronics, and industrial control systems. Circuit boards should have their own designated collection stream, so they are not damaged by heavier materials. Cables, adapters, chargers, and power supplies should also be organized separately. Proper sorting makes it easier to identify reusable items and prepare unusable materials for recycling. Data-containing components require controlled handling. Hard drives, solid-state drives, memory systems, and certain controllers should not be placed into unrestricted component containers. Collection containers should be stable, appropriate for their contents, and clearly labeled. Labels should identify accepted materials and show which items must not be placed inside. Organized separation protects materials from damage, improves workplace efficiency, and helps licensed recyclers evaluate and process electronic materials more effectively. Electronic waste should be stored in a designated area that remains separate from ordinary trash, active equipment, and general supplies. Moisture and excessive humidity can corrode circuit boards, connectors, batteries, and metal components. High temperatures can accelerate battery deterioration, while extreme conditions can damage displays and other sensitive electronics. Heavy items should never be placed on top of fragile devices. Poor stacking can crush batteries, break screens, bend circuit boards, and destroy components that might otherwise be reused. Storage containers should support the size and weight of their contents without tipping, collapsing, or allowing materials to spill. Damaged batteries and broken displays may require more protective storage arrangements than intact equipment. Every container and individual item should have a visible, readable label. Useful information includes the equipment type, condition, date received, original location, and intended next step. Electronic waste storage should remain temporary. Periodic reviews can identify overflowing containers, deteriorating equipment, missing labels, and items that have remained unused for too long. Not every retired electronic device has reached the end of its useful life. Functional equipment may be transferred to another department or used for a less demanding application. Working motors, sensors, displays, cables, power supplies, and communication modules may also be retained as replacement components for compatible systems. However, reuse must be intentional. Organizations should document why an item is being retained and identify the active equipment it is expected to support. Condition and compatibility should be verified before a component returns to service. An item may look acceptable but still be unsuitable for a particular system. Accessories should remain with their equipment whenever possible. Chargers, adapters, cables, mounting hardware, and manuals can significantly improve the usefulness of a device. Items that no longer serve active equipment should not remain in storage indefinitely. Obsolete components consume valuable space, complicate inventories, and eventually become forgotten electronic waste. When equipment cannot be reused, organizations should work with licensed recyclers and confirm accepted materials, preparation requirements, and collection arrangements. Repair and maintenance can significantly reduce electronic waste. A device with a failed battery, sensor, display, motor, or power supply may not require complete replacement. If the larger system remains functional and suitable for continued operation, replacing one component can extend its useful life. Preventive maintenance also helps reduce avoidable failures. Cleaning, inspections, software updates, and appropriate battery care can preserve equipment reliability. Maintenance records are essential for determining whether repair remains practical. They can show failure frequency, replacement history, repair expenses, downtime, and the overall condition of the equipment. Repeated repairs may eventually indicate that a device has reached the end of its practical service life. Compatibility, security, software support, and parts availability should all be considered. Once a repair is rejected, the equipment should move promptly into an approved reuse or recycling process. It should not return to an unmarked storage area where it may be forgotten. Some electronic components can store information even after they have been removed from equipment or disconnected from power. Hard drives, solid-state drives, computers, controllers, memory systems, and connected electronics may retain business records, customer information, employee data, network settings, passwords, or operational configurations. Removing a storage device from its original machine does not remove the information it contains. Before data-bearing equipment leaves organizational control, required information should be backed up, transferred, or archived. Sensitive data must then be managed according to the organization's established security procedures. These components should not be placed in open or unrestricted collection bins. Controlled handling creates a clearer chain of responsibility and reduces unauthorized access. Data management actions should be documented. Records may identify the device, storage component, date, method used, and employee responsible for completing the process. When working with licensed recyclers, organizations should clearly identify data-containing equipment and confirm how it will be transported, processed, and documented. Employees who use, repair, maintain, or remove electronics play a central role in responsible waste handling. Training should help workers recognize battery-containing devices, including products with batteries hidden inside sealed housings. Employees should also learn to identify warning signs such as swelling, leakage, punctures, deformation, broken displays, exposed wiring, and unusual heat. Collection instructions should be simple, visible, and easy to follow. Clear labels, illustrated examples, and consistent container colors can be more effective than complicated written procedures. Reporting responsibilities must also be defined. Employees should know exactly who to contact when they discover a questionable battery, unidentified component, or damaged electronic device. Maintenance and repair personnel should document removed components instead of placing batteries, boards, drives, and power supplies into unmarked containers. Cleaning teams should also receive guidance because they may be the first employees to find electronics left in storage rooms or mixed with ordinary trash. Periodic reminders can reinforce the procedures and introduce changes involving new equipment, battery types, or collection arrangements. Accurate inventory records can prevent electronic components from accumulating unnecessarily. Every stored item should have an identifiable purpose. Records should indicate whether the equipment is awaiting repair, approved for reuse, retained as a replacement part, or scheduled for recycling. An effective inventory can include the component type, condition, manufacturer, model, compatibility, storage location, date received, and intended use. Compatibility information helps technicians find available replacement parts and reduces unnecessary purchases. Storage locations must also be updated whenever materials are moved. Periodic inventory reviews can identify components that have remained unused for extended periods. Items that no longer support active equipment can then be evaluated for removal. Inventory data can also reveal broader problems, including over-ordering, duplicate purchases, inconsistent maintenance, and poor equipment planning. Battery and component waste is not limited to small consumer electronics. Industrial machinery, robotics, transportation equipment, emergency systems, automated tools, and other large technologies may contain substantial batteries, control boards, computers, sensors, and data storage systems. Before large equipment is moved, employees should identify its batteries, electronic controls, reusable accessories, and data-bearing components. Control panels and communication modules may need to be separated from frames, plastic housings, and mechanical hardware. Chargers, cables, tools, mounting equipment, and manuals should be labeled so they remain connected with their intended equipment. Because large devices may require forklifts, specialized transportation, and trained personnel, movement and dismantling should be carefully planned. Licensed recyclers should receive accurate information about equipment dimensions, weight, condition, battery presence, and loading requirements before collection. A responsible battery and component program begins during purchasing, not disposal. Organizations can consider product durability, repairability, battery replacement options, and parts availability before acquiring new equipment. During service, maintenance and component-level repair can prevent premature replacement. When equipment is no longer needed, practical reuse opportunities should be evaluated. Once retirement becomes necessary, materials should be inspected, separated, labeled, and placed into temporary managed storage. Data containing components and damaged batteries should receive additional attention. Licensed recyclers should be included in the final stage of the process, so batteries, electronics, and components can be prepared and collected appropriately. Through better purchasing, maintenance, repair, reuse, storage, and recycling practices, organizations can maintain cleaner workplaces, improve inventory efficiency, protect important information, and reduce unnecessary electronic waste. For more information about responsible battery and electronic component recycling, contact us by phone, email, or through our website. Handle batteries and electronic components thoughtfully today to create safer workplaces, recover valuable materials, and build a more responsible technological future.